Good afternoon, ladies and gentlemen. Thank you so much for being here with me. For today, we are going to be discussing manganese and its efficiency. According to the Encyclopedia of Britannica, manganese is a chemical element, one of the silvery white, hard, brittle metals of group 7 of the periodic table. Manganese is a chemical element with the symbol Mn and atomic number 25. It is a transition metal with a multifaceted array of industrial alloy uses particularly in stainless steel. Manganese combined with other elements is widely distributed in Earth's crust. It is second only to iron among the transition element in its abundance in Earth's crust. Manganese occurs in a number of substantial deposits, of which the most important are consist primarily of manganese dioxide in the form of pyrrolizite, romanicite, and wood. Manganese is essential to plant growth and is involved in the assimilation of nitrates in green plants and algae. It is an essential trace element in higher animals in which it participates in the action of many enzymes. A lack of manganese causes testicular atrophy, and excess of this element in plants and animals is toxic. Manganese ores are primarily produced by Australia, South Africa, China, Gabon, and Brazil. Most of the manganese produced is used in form of ferromanganese and silicon manganese alloys for iron and steel manufacture. Manganese ores containing iron oxides are first reduced in blast furnace or electric furnace with carbon to yield ferromanganese, which in turn is used in steel making. Manganese steel is used for a very rugged surface containing 11 to 14% manganese. It provides a hard, wear resistant, and self renewing surface over a tough, unbreakable core. Pure manganese produced electrolytically is used mostly in the preparation of non-ferrous alloys of copper, aluminum, magnesium, nickel, and the production of high purity chemical. Almost all commercial alloys of aluminum and magnesium contain manganese to improve corrosion resistance and mechanical properties. The principal industrial compounds of manganese include several oxides. Manganese oxide or manganese monoxide is used as a starting material for the production of manganese salt, as an additive in fertilizer, and as a reagent in textile printing. It occurs in nature as a green mineral manganosite. It can also be prepared commercially by heating manganese carbonate in the absence of air or by passing hydrogen or carbon monoxide over manganese dioxide. The most important manganese compound is manganese dioxide, in which manganese is in the +4 oxidation state, and the black mineral pyrrolizite is the chief source of manganese in all its compounds. It is also used as a chemical oxidant in organic synthesis. Manganese dioxide is used as the cathode material in dry cell batteries. It is produced directly from the ore, although substantial amounts are also prepared synthetically. Various manganese salts also have commercial importance. Manganese sulfate is added to soil to promote plant growth, especially citrus crops. It is a good reducing agent, particularly useful in the manufacture of paint and varnish dryers. In an article written by James Darwin, we learned that manganese is an allotropic metal, that is, its crystal structure changes with temperature. While cooling from the melting state down to 1138 degrees Celsius, it solidifies into a body-centric cubic structure called the delta phase. From that point down to 1100 degrees Celsius, it is in the face-centric cubic gamma phase, and from this point down to room temperature, it goes to the beta and alpha phase. Manganese metal oxidizes superficially in air, rusts in moist air, and burns in air or oxygen at elevated temperatures. It decomposes water slowly when cool and rapidly when heated, forming hydrogen gas and manganese hydroxide, and it dissolves readily in dilute mineral acids, generating hydrogen in various manganese salts. The chemical reactivity of the metal accounts for its utility in metallurgy and in various chemical compounds. The most important manganese ores are pyrolusite, womanite, manganite, and haussmannite, and the carbonate or rhodochrosite. Rhodonite and braunite, both silicate ores, are frequently found with the oxides. Only ores containing greater than 35% manganese are considered commercially exploitable. In addition to terrestrial sources, manganese is present in models that are distributed widely over the seafloor. The mining of manganese ore is done in open pits. Some ores are upgraded by washing, and undersized ore can be agglomerated by sintering. Several processes have been developed for mining seafloor models, but they cannot compete economically with the ready exploitation of high grade terrestrial deposits. Pure manganese is produced by hydrometallurgical and electrolytic processes, while ferromanganese and silicomanganese are produced by the smelting of ores in a blast furnace or, more commonly, in electric furnace. More than 90% of the manganese produced gas into metallurgical applications, the pure metal being used in copper and aluminum alloys, and ferromanganese and silicomanganese employed in steel and cast iron. Manganese is a crucial mineral that is a part of the rare earths globally. It is found in many parts of Ayiti in various ore, especially womanite. Understanding the value of the land of Ayiti, bringing more environmental experts practicing safe mining will then place our country in the trading export lane, which will begin structuring our leverage as well as our future development. Thank you so much, ladies and gentlemen. I hope that this information was very helpful to you. I will see you in the next.